Hello everyone, welcome to Sai Tutorials Jamkandi. In our tutorials, 10th class Kannada medium, English medium, math, science, English classes are available in the regular classes as well as in the online classes. So please join us and learn the things. So dear students, in this today's session, let us learn about the third chapter of the physics second PUC, that is current electricity. So in the previous session, I have discussed some concepts related to your syllabus, that is cells, grouping of cells, cells in series and cells in parallel combination, and mixed grouping of cells. So what is the maximum power transfer theorem? So and see maximum power transfer theorem and electrical energy power. So I have told you that heat dissipated in a conductor, that is H. Okay, H is equal to V into I into T. So we can also write Vi in case of I in case of V by R. So that's why it will become V square divided by R, where I is equal to V by R. So it will become V square by R. So it can also be written as I square into R into T. So where power dissipated is P is equal to Vi. So I is V by R. Therefore, it will become V square by R. Finally, we will get I square into R. And the most important concept related to your syllabus, that is the most important Kirchhoff's law. See, we have two phenomena here, Kirchhoff's first law and Kirchhoff's second law. Okay. So this is very important concept, that is Kirchhoff's first law and Kirchhoff's second law. See, Kirchhoff's first law will define you that, see, this law is also known as a junction rule or current law, that is current Kirchhoff's current law, KCL. Okay, it is also known as a junction rule, okay, or a current law. To this, the algebraic sum of, okay, the algebraic sum of the currents meeting at a junction 0, meeting at a junction 0. So in a circuit at any junction, the sum of the currents entering the junction must be the sum of the currents leaving the junction. So what this Kirchhoff's first law will say you that this is the algebraic sum of the currents. Okay, algebraic sum of the currents. Whatever the currents you are applying to that junction, meeting at that junction will be 0. So in that circuit, at any junction, the sum of the currents entering the junction. See, the sum of the currents entering the junction must be equal to the sum of the currents leaving the junction. See, this is the junction point. Okay, the arrow mark towards this junction is the one type of current. Okay, arrow mark towards that junction is one type of current. You can see in the diagram here, and it is also equal to the sum of the currents leaving the junction. Okay, leaving the junction. So sum of the currents entering the junction are I1 and I3. Is it or not? This is equal to the I1 plus I3. And also the sum of the currents leaving the junction, those are I2 plus I4. I2 plus I4. So this law is simply a statement of conservation of charge. It is also this simply a statement of conservation of charge. So let me give you an example for this Kirchhoff's first law. or Kirchhoff's first law. See, the algebraic sum of all the currents meeting at a point or a junction in a closed electric circuit is 0. See the statement. Please note down it. The algebraic sum of all the currents meeting at a point or a junction in a closed electric circuit is 0. See, this can also be written as is equal to 0. This is the statement for Kirchhoff's first law, Kirchhoff's current law. So let me give you an example of Kirchhoff's first law. Okay, let us consider a junction. Wait. See, let us consider a junction here. This is the junction point. See, suppose this is R1, this is R2, this is R3, R4 and R5. These are the resistors. Now, the direction of current coming towards, current entering towards the junction, those are I1, I3. Let us consider I1 and I3 are the current that entering towards the junction. Okay, the arrow mark should be towards the junction. R1 and let us consider R1 and R5 are towards the junction and R2 and R5 are towards the junction and I2 let us consider R1, R3 and R4 are away from the junction. This is the junction point O. Now consider a point or a junction O in an electrical circuit. So let I1 and I3 be the currents entering the point. So let us consider this one as I1 and this one as I3. And the current, this one as I2, this one as I4 and this one as I5. Okay. So these are the mentioned currents entering and leaving the point O. So now according to Kirchhoff's first law, what will say? It will say that the sum of the currents entering the junction. What are the currents here entering the junction? I1 and I3. So those are equal to the currents leaving the junction. So that is equal to the I2 plus I4 plus I5. Is it or not? So these are the equations. Now we can also write it as, so if RHS side of the currents will come to LHS side, this will become minus I2 minus I4 minus I5, or you can also write it as I1 plus minus I2 plus I3 plus minus I4 plus minus I5 is equal to 0. So according to the Kirchhoff's first law, the total current entering or leaving the junction is equal to the sum of all the currents is equal to the 0. So thus currents entering the point can be taken as a positive, while currents leaving the point can be taken as negative. So this is all about the Kirchhoff's current law. Now this is all about the Kirchhoff's current law. Now, so this is all about Kirchhoff's current law. If you consider Kirchhoff's second law, this is also same. Here conservation of charges will takes place. But in case of Kirchhoff's second law, see, this law is also known as a loop law or a voltage law. Kirchhoff's voltage law. So according to this, the algebraic sum of changes in potential in complete transfer of a mesh or a closed loop is equal to 0. See, the algebraic sum of the algebraic sum of all the voltages, that is potential differences across all the elements and EMFs of all the sources in any closed electrical circuit is 0. So this is the second law. In the same way, here we have considered the sum of all the currents, but in case of Kirchhoff's second law, it is the sum of all the voltages or sum of the algebraic sum of the potential differences across the all the elements. And also if you consider the EMF, see, sum of all the EMFs and sum of all the voltages or potential difference is equal to 0. This is the Kirchhoff's second law. So this law represents conservation of energy. Represents a conservation of energy. So why it will be conserved here? Because the voltages towards the junction will always be equal to the voltages away, I mean moving away from that junction. So these are called as a Kirchhoff's second law, where there is a conservation of energy will takes place. So if there are any n meshes in a circuit, a number of meshes, like there will be consisting of a cell or a EMF or a resistors. So like this. So if you consider cell, so in that, if it is like a mesh means a circuit having different kinds of uh, so this is called as a mesh. If suppose there are n meshes in a circuit, the number of independent equations in accordance with the loop rule will be n minus 1. n minus 1. So sign convention for application of Kirchhoff's laws will be, for the application of Kirchhoff's law, following sign convention should be considered. So those are, first one is the change in potential in transverse swing resistance in the direction of current is minus I into R. Whereas while the opposite direction is plus I into R. You can clearly observe the sign conventions here. Suppose the resistance is in the direction of the current, the total potential in transferring the resistance will be equal to the, that is negative IR, while suppose it will be in the opposite direction, it is equal to the plus IR. It is in the direction of opposite to the current. So second one is the change in potential in transforming an EMF source. Okay, the change in potential, suppose if you consider the potential in transversing the EMF source from negative to positive terminal is plus E. Okay, from negative to, this is, suppose if you consider This is plus and this is minus. Okay. The source from negative to positive terminal is plus E, while in the opposite direction, my negative E, irrespective of the direction on current in the circuit. This is minus E from positive to negative. And the change in potential in transversing the capacitor from negative terminal to the positive terminal is plus Q by C, while opposite direction, that is minus Q by C. Okay. From whatever the, I mean, terms, whatever the factors, like whether it may be cell, or whether it may be EMF, or whether it may be resistance, or the flow of current, the direction will depends here. The direction will depends here. Suppose if you consider the capacitor from negative terminal to the positive terminal, it is plus Q by C, while in opposite direction, it is equal to minus Q by C. If you consider the change in voltage here, okay, change in voltage here, in transversing an inductor in the direction of current, it is equal to minus L dive L in the I'm saying you that in the direction, according to the direction of the current, it will be negative. That's why it is equal to inductance, that is L is equal to inductance. Okay. While in opposite direction, it is equal to plus L di divided by dt. So these are all the phenomenon related to the Kirchhoff's law. Okay. This is very very important concept here. Kirchhoff's first law, this is the algebraic sum of all the currents at a junction will be equal to 0. Well, the Kirchhoff's second law will say you that algebraic sum of all the voltages, or the all the potential differences and the EMF considered in the circuit in the mesh equal to the 0. So sign convention will be mentioned here. So please note the change in potential energy and the change in potential in transversing the EMF source, and change in the potential in transversing the capacitor, and also transversing an inductor. Okay, inductor. So these are all the concepts related to the Kirchhoff's law, which is very very important to your syllabus. So in the so this is all about the Kirchhoff's law. There is a small concept related to your syllabus, that is Wheatstone bridge. So it may take some more time to discuss whole thoroughly. So I'll discuss in the next session. And this is enough for this session. So I'm going to wind up this session for today itself. Please note down whatever I have said you in the class. This will help you in one or the other way. Please make a short note and understand the things quickly, and note down in your own words, and it will help you in the examination part of time. Okay. So by saying this, I'm going to wind up this session for today itself. So tomorrow I'm going to tell you that measurement of resistance in case of principle of Wheatstone bridge. So it will be important for your 5 marks question it is. Okay. Thank you.